All right, welcome to another digital forensics video. Um, I'm gonna name it, thanks to Kevin Pagano's idea, Differ Bits with Briggs. So we'll be quickly discussing a topic that I find interesting, or tools that I find interesting that might help you with your cases. Right. So today I want to talk about briefly about iTunes backups. What are they? We use them all the time in mobile forensics for iOS, and I want to show you maybe a couple of scripts that might help you squeeze some more data out of those iTunes backup with your tools, with your forensic tools, right? So for the iTunes backups that we're gonna discuss, I took for this testing and this these examples, Josh Higman's images. They're pretty good. They're publicly available, and within those images, iOS full file system images, he also kindly included an iTunes backup of the images as well, so we can work with them. So there they are. You can get them at the binaryhate.blog. Okay. So I downloaded them, and how they look. Well, they look like this, right? This is how an iTunes backup looks, right? And again, iTunes backups are generated by you either taking the phone and hooking it up to your computer and doing a backup, or by doing a backup to the cloud, and it generates that data, but it's, obviously it pushes it up and it's kept there, and it can be downloaded and recreated on that phone if need be, or from the computer. When that process occurs, the end product of it is these directories, right? And within them they have some files. These files are named pretty uniquely. Visually doesn't tell you much, but the secret or the conversion key for those resides in the manifest.db database. All right. If you have an older iOS extraction, it might be named differently, but same concepts apply. Right. Assuming the database is not encrypted, because it could be, and then it's another issue. You have to decrypt that. But assuming it's not encrypted or already decrypted, you can open it, and if you look what's in it, you will find this. Right. You will find the file IDs or file names that we were looking at, and they're related, or they're kind of correlated here with a domain and a sub, there we go, and a relative path here. Okay. All right, so let me minimize this so I can have it in all one view. So this part on the right I do understand. I know what these are. For example, look at this file, image image underscore 0017. Sure, it's in the Apple folder for DCIM, the cameras. I understand that, but what is camera roll domain? And if you're familiar with iOS extractions, full file system iOS extractions from a jailbroken iOS device, I haven't seen any camera roll domain directories in it. So what does that mean? Well, what Apple does is, and let me give you an example here. What Apple does is it takes the path within the device, how it will look on the device, and it maps it to a domain for the backups, right? The camera roll domain within the phone is actually at var mobile, and if you look again at a full file system extraction, it starts with private var mobile. Okay, and same with all the other different domains, they have a counterpart within the file system, right? So when the tool reestablishes that data back into the phone, it will do that conversion. Camera roll domain, the data will go into var mobile and the rest of the relative path within it. Okay, now why is this of importance? Well, some of our tools will go through the iTunes backup as is. It has parsers. It will go through it and pick out stuff that might be of interest to you. And if you look at your forensic tool, it will in the source of the data, it will show you these. Oh well, I found it at this directory E5, and the file name is this, and it happens to be whatever it is, a picture, a database, whatever data is, and that's okay. That's good. Some of our other forensic tools, what they might do is take the iTunes backup and convert it, recreate the file system as instructed here in the manifest.db. So you will go and put all these files, rename them as accordingly as the relative path has them named, and puts them in the domain folder for appropriately. Camera roll domain, if it's the camera roll domain, there's more. If it's the app domain, if it's the home domain, whatever the domain is. And then the tool parses that. Okay? So Edward Graybeard here, and again, that's not his real name, it's a pseudonym. Where are we? He thought, and I think it's a pretty, creative thinking there. What happens if, and he made a tool for this called iOS BackUpOnFunker, which I find pretty funny. What happens if we take, and instead of just taking the iTunes backup and put it in this, recreate the file system as the domains, right? What if we go a step further and recreate the file system all the way to the iOS full path format, right? Why we normalize it to how it will look inside the phone? And if we did that, and then we feed that to our tools, will we get anything different? Will we get more? Would we get less? And I think it's a pretty smart thought, because some of our tools, at least behaviorally, because unless you have access to the source code, you don't really know. But behaviorally, it seems behavior of the tool, it seems that some tools have these routines that will be used for iTunes backups, and have some other routines that will be used for full iOS full file systems, or iOS data that conforms to the file paths in an iOS device. And if you feed out an iTunes, this will kick off the iTunes one. If you feed the file system, this will kick off. Well, what we're doing then is taking the iTunes and making it seem as a full file system and feeding it to kick these processes to the backup to see what we get. And in many cases, we might get even more, which interestingly enough, with our own already working tools. Okay, so let me give you an example of how we can take the iTunes backup and show you how to do it with this tool and convert it to the full paths within the device. Again, we're using Mr. Graybeard here, Graybeard's iOS BackUpOnFunker. I think I have it already on screen here. Let me see. I do not, but we're gonna open it. So let's go. Like always, you're familiar with GitHub. What you do is, download it and open the zip file and run it. I'll be remiss if I don't talk about one tool before I continue. If you're interested in seeing how the iTunes backup from here looks as recreated as domains, there's a tool for that. So I should say that before we continue. Jack Farley, and we talked about his tool, one of his tools last time. This one, the iTunes backup reader, it goes to the iTunes backup again, provided it's not encrypted, and it will take the data and put it within the domains that it needs to be, right? So you got to go to GitHub jfarley248 and get that. And when you run this script, you download and you run it. I'm not going to run it for sake of time. What you're going to get is a recreated file structure as domains. As you can see here, all the domains. Let's go down to the bottom one and let's look at the wireless domain. Wireless domain, library, databases, and here they are, right? So it took the files, renamed them properly, put them in the relative path structure all the way to domain, to the domain it belongs. And you can run your tool and you can run it and have it parse and see what you get, right? So that's how it would look, right? And we will do that in a second. Another way, which is the one I'm discussing, we're going to run right now, is we're going to take, let me take this out of the way here, I don't need it for now. We're going to run this tool here, Mr. Graybeard's tool, like I said. Don't make me wait. All right, there we go. Okay. So let's look here at the help so we can figure out what do we need. Okay. All right, so we need an input directory, an output directory. That makes sense. And I like this option, this -c option for zips, right? Most of your tools will work with zips, and I found out, at least on my tool sets, the ones that I make, working with zip files is quicker than trying to parse data sitting on the file system. So I like zip a lot, right? So let's create that. So let's go again, and we have that. We need -c. So we need the input. So we're gonna feed it. Oops, we're gonna feed it Hickman's data. So it's right here. So let's just drag it here so we can type it. Perfect. Now we need the output. Give it a space, And for output, we're just going to leave it at the root of this folder so we can find it easily. So there we go. I think we have everything. Let's kick it. Right? It's running. The tool is running, giving us some different things we need to know. Or so here it is. UNF backup.zip is being created and is done. Right? So let's see what it has in it. All right. See private, var, and all the the domains are recreated as it would look on an iOS device. And let's go to wireless. The first one here, library, databases, and here they are. You saw that? Remember we did previously with domain recreation? Same thing, this just goes a step further, right? A step further. Great. So it's another way of kind of attacking those iTunes backup, and now they look like if they were iOS full file system extractions. And again, emphasis on as if they were, right? Because it is not an iOS full file system backup. It's an iTunes backup that we're making it look as it would look if we were inside that phone. Okay? So keep that in mind. It will not magically give you more data. It works with what's there. Okay, perfect. Now, the next step is, all right, so we have these two ways of looking at our iTunes backup, at least for this example. We have it the domain style, normalize as it will look on the phone style. So let's run our tools on the domain one and see what we get so we can make some comparisons. For this example, I'm going to use my own tools. I highly recommend you do this with your own tool sets to include vendor ones that you have bought. Okay. All right. So let's run the graphical tool for my parser, iLeap. It does iOS, and notice how my tool I designed it to target iOS full file system extractions. But that doesn't mean that we cannot point it towards the domain recreation of an iTunes backup and see what we get. So let's go into that input folder, and I'm gonna no, that's not where I need to be. I need to be in the iTunes backup reader. Yep, here it is. Yep, you created file structure as domains. That's what I need. Point it to that folder. Perfect. I'm gonna output it to the folder for the next step, which will be here. Okay, and we're just gonna let it run. Right, so the tool started. As expected, some files will not be found because again, this is not an iOS full file system extraction that we're parsing. We're going through an iTunes backup that's been recreated, a file system recreated as a domain style recreation there. So you can see here, you can see some artifacts kind of popping up, right? Install apps is showing up, accounts is showing up, the call logs are showing up. You know, all good. Just a few more seconds, and it will be done. Okay. SMS messages were pulled. The screens were pulled. That's good. For example, look at Knowledge C. Knowledge C is an artifact that you can only get from an iOS full file system extraction. So that makes sense. Okay, so it's completed. When it's complete, my tool gives you a little pop-up telling you that it's done. We're gonna hit OK and open the report, and here it is. So we have 1, 2, 3, 4, 5, 6, 7, right? Yeah. 3, 6, 7 artifacts that it pulled. That's pretty neat, right? By the way, this is iLeap 1.2. I'm still adding artifacts, porting them from the old version, so there'll be more artifacts that it will be supporting in the coming weeks. All right. So now let's do the same, but let's do it with the normalized paths, right? As they would have looked in in the phone itself. The same thing. We're running the tool, and since we did the conversion with the iOS.unfunker, we're gonna grab that zip. It's a file, so we're gonna grab that zip. It's right here, UNF backup zip that the tool created for us, and the output folder. We're gonna put it here for the output folder, and we're gonna run it. As you can see, immediately it's quicker. Like I mentioned, zip files are quicker to work with, and it's already done. And here's our pop-up here. I got two screens. Put it on the other screen, but it's all good, and it's done. And here's the report. So let's count. I have 1, 2, 3, 4, 5, 6, 7, 8, 9. All the way to the bottom, 9 artifacts, right? And if we look at these, we're missing one. We're missing. Let's take one. Let's take cellular wireless, right? So we press that one. You see that it was able to parse the phone number for the device. That's pretty neat. The last known look, the network phone number ICC ID, so it might be useful for identification of those devices, numbers used. Does that make sense? So what we did was pretty much, again, this side doesn't have it. By normalizing the paths, we give the tool a chance to be able to find more artifacts if the path is important to the tool for identifying the artifact and showing it to you. Okay, so in my testing that I've done, I found out in some cases that when we normalize the paths this way, your forensic tools will get more out of it. In some cases, you might get the same stuff. In a few cases, you might get less. And you're saying, well, okay, well, this is just a technique that you can use as needed, right? If you need it to use it, have a case that's important, it doesn't hurt to normalize the paths, feed it to your tool, and see what more can you get. You might be able to get more data out of it. So let's go here to, again, to Mr. Graybeard's github.com, Edward Graybeard. Actually, let me just show you here the different things. This is my Twitter, my blog. Here you can get the iOS full file system path normalization script. If you want to do it domain style from Jack Tools, there it is, and the images, free images for your testing and research from Josh Hickman at thebinaryhig.blog. So the big takeaways: understand your data sets. Understand how an iTunes backup looks when it's made by the tool, by the iTunes backup tools, by the phone. Understand what the formatting is, what's a domain, where it's kept in the manifest.db databases or different ones for that purpose. And understand that these can be normalized to look as they will look when it's restored into the phone, and it might help in your investigations to do that. Run it by your tools, and you may be able to squeeze a little bit more information out of your data set. That's all I got for today. Thank you so much for watching, and I'll see you next time.